Hi everyone, welcome to this tutorial. In this course, we're gonna see how to do a binary counter with 4 LEDs. To do that, to do that, we need uh we need an Arduino, a breadboard, 4 LEDs, resistors, and some jumper wires here, as you can see here. Okay. How we gonna proceed? Let's place our LED in the circuit, in the in on the breadboard. Sorry. So this is the breadboard. One. Okay. This is green. Um, Blue. And yellow. Okay. We add our resistors, short leg to GNG, short leg to GNG, short leg to GNG, and short leg to GNG. Well, let's go now. This is the long leg of the red LED is connected to digital pin. Let's say uh, so this is the yellow one, the green LED, and the blue one. Okay. The yellow LED is the yellow pin goes to digital pin number 2 of the Arduino. The blue one to digital pin number 3. The green pin to digital pin number 4. And finally the red pin. Oh, sorry, let's change the jumper wire. And this is where the digital pin. Okay, very good. Don't forget, this is the GNG. Here you have the GNG to the GNG of the Arduino. Perfect GNG of the Arduino. What else? I think that's all. Now we need to write our code. Okay. The first thing that we need to do is to initialize our pin by in a table. So let's say int LEDs pin. The size of the table is 4. So we have here digital, we have 2, 3, 4, and 5. Okay, I think this is good. Let's go for the setup function. For let's say int I begin by 0 and I degrees and I is inferior to 4 as is incrementally. So then we write pin we read the pin mode uh let's say LED I, and this is and the R output. Okay, let's do the same thing in the loop function. So for let's say int uh, number begin by 0, number is inferior to 16, number plus plus, then uh, for int bit receive 0, the bit is inferior to a full bit plus plus, then the ground was user white. Let's say LEDs for each LED bit width, number and bits. Okay, and then the delay time. This is 1000 millisecond. It is 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 millisecond. Is milliseconds. Okay. Now so we're gonna count here. We count from we count uh from from 0 to 15. As you can see in the loop, the the number 50 is not included, so the number is inferior to 16, so it doesn't count, it doesn't take 50 into account. Okay, right. So the code is ready. We can we can verify it first of all. Oh, it was okay. This is what of digital right. I was not declared in this scope. Okay. Okay. Int number. Okay. Uh, where is the error? Can you see it? Ah, sorry. Ah, here you put I. It's not I, it is bit. So we can correct it. This is bit. Verify again our code. Very perfect. Working. So let's connect our Arduino. We observe will work. Wait. Upload the code. What's going on? Normally we should start. Uh, I think this is not the right order. We start by digital pin number 4. then two, then five. Okay, what's going on? Let's troubleshoot our circuit. Okay, let's change position. This is two. This is sorry. Right. Okay. Very good. I'll put it again because ah the bar is not sorry. We should connect the Arduino. Right, it is connected successfully. Upload this again. Uh, what's wrong here? Um, honestly, I can see the mistake in the code. I think it is correct. Let's upload it again. No, sorry. Let's verify the code. Correct. What's wrong? Let's check our circuit. Maybe something is wrong here. There. Oof. Tak. Let's check again. Ah, yeah. Can you see it? Let me show you. The short leg of of LEDs, green, sorry, blue and yellow are connected to nothing because this this wall is not supplied by any current. So we put it here instead of in the negative uh, negative the negative ingredient, sorry. So what you need to do is to change it. This can happen while building your circuits. So sorry for that, and I hope that this is not damage the quality of the code. Sorry. So let's change it. It is 0 GND perfect. Now it can work. Uh, let's upload again because to see what will happen. Perfect. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 0. So, as you can see, this counts. This is a four binary code that go from 0 to let's say 15. But we can improve that circuit by adding, if you want, uh, by adding a push power. So improve the circuits. Let's do it together. we're going to unplug our circuit. Uh, where is the push button? Here you have, this is the push button. Okay, this is the push button. Okay. What else? This is, let's say, this is this is the GNG. This is the GNG. Okay. Uh, 5 volts. 5 volts. And let's say, mm, yeah, this is laser pin. This is digital pin. Uh, this jumper wire is so short. Let's replace it by a longer one. This is digital pin number, let's say 8. Let me show closely the circuit. Can you see it more closely? All right, wonderful. Can you see it? Okay, wonderful. Let me show you again. Very good. Now, let's go to modify our codes. Maybe something can work. Okay. Binary. What will happen? Um, let's say this is int. The button, the push button, push the button pin. It's digital pin number 8. Int let's say counter equal to 0. The button state int button state equal to 0, and the last bottom state equal to 0. For int equal to 0 of, okay, very good. This is pin mode. Let's say button pin. This is an input, right? This is an input. Perfect. After that, let's go for the void function. Sorry, void loop function. Here you have the button or the button state, which receive the digital digital reader, which is a read. We read the button state sorry, pin, right? And then if the button is pressed, so if the button state is pressed here, let's say high, on the last button state uh, is low, then what will happen? Let's say uh, counter start to increase, and if the counter is superior to 50, let's say that counter go to 0. Okay, this is a case. And if so, for for let's say int the bit start by 0, bit is inferior, let's say full to full, on bit plus plus, what will do, what is happen, digital white LEDs I sorry, not I, here it is byte, bits, bit, bits with counter and bits. Okay, the delay time should be delay, this is let's say 200, and finally the last button state will change, the equal is initial to button state. Perfect. Let's verify our code. Maybe I hope it will work. If and if, oh sorry, there is more bracket here. Okay, let's verify again the code. Okay, wonderful, it's working. We start. Oh, sorry. Plug your Arduino. Let's plug it. Perfect. Okay. Upload. Very good. So to start counting, we need to push the button. But initially, the first time, as you can see, nothing, any LEDs are turned on. So to start, we need to press the push button. This is 1, 2, 3, 4, 5, 6. Okay, let's go. Okay, this is 15, and then we go back to 0. Right, very good. Can you understand this? Let me show you, or let me explain you the principle behind this binary counter. Okay, let's move this. Okay, very good. This is a sheet of paper. Let me show you the principle. We count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and uh, and 15. Sorry, and 15. So we start by 0, 0. So 0, 0, 0, 0. Then 0, 0, 0, 1. After that, it is uh it is uh after that it is 0, 0, 1, 0, 0, 0, 1, 1, 0, uh, 0, 1, 0, 0. Okay, this is 5. This is 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0. No, this is sorry. This is 1, 0, 0, 0, 1, 0, 0. Sorry, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. This is 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and 1, 1, 1, 1. Very good. And after 15, we come back to 0. That's all. So let's try again. We have 1, uh, so 1. Oh, I don't know. Maybe something's wrong. So as you can see, the jumper was the circuit. Maybe something get wrong here, but you can fix it clearly. So we hope that you understand the principle or the concept behind binary counter, how to use LEDs to do that, and this is very important in many applications. So that's all for this video. See you for the next time. And we hope that you enjoy this tutorial. Goodbye.